Today we're looking at Notes 3-6, Introduction to Matrices. So today I am learning matrix terminology and will be able to identify important parts of a matrix. So what is a matrix? A matrix is a rectangular array of numbers or elements enclosed in brackets. Okay, so when identifying a matrix, you are going to always use a capital letter, such as this one here. This is matrix A. Notice that's a capital letter. Okay, and this matrix contains a bunch of numbers, 3, 1, -4, 0, 7, and 15. Remember that these individual numbers within the matrix are also called elements, as I discussed above, elements. Okay. And also the matrix has what we call rows. So 3, 1, and -4 are row 1. 0, 7, and 15 are in row 2. So those are called rows, the horizontal parts of the matrix. The vertical parts of the matrix, like 3, 0, 1, 7, -4, 15, those are called columns, as you might have imagined. So similar to a building. Has columns up and down, vertical, okay? So 3, 0 are column 1, 1, 7 column 2, and -4, 15 are in column 3. So when you talk about a matrix, you usually give its dimensions. That's like sizing it up, telling me the size. Dimensions means the number of rows by the number of columns. Okay, so if you were to ask me what are the dimensions of matrix A, I would say, well, matrix A is a 2 by 3 matrix. That means it has 2 rows and it has 3 columns. Okay, so as not to confuse, we always just say rows first, columns second. So this matrix has 2 rows, 1, 2, 3 columns. Okay, so how about identifying a matrix element? Okay, an element within a matrix. So if, for example, I ask you on example 1, what is the element A23? Well, that means look at the matrix A. When we're talking about an individual element, though, we utilize lowercase letters. So this is saying look at the matrix A and find the element 23. Okay, and just like dimensions, the elements are also labeled by row, by column. So this means which number, which element is in the second row, third column. Well, this is the second row, 0, 7, 15. Which one of these is in the third column? Well, this is the first column, second column, third column. So that would be 15. That's what it's asking for. What number, what element is in the second row, third column? Similarly, on example 2, I'm asking for the element A12. That means which number or element is in the first row, second column. So first row would be 3, 1, and -4. The second column would be 1, because that's the first column, second column, third column. So that answer would be number 1. Okay, so what's the whole purpose of learning about a matrix? Well, good question. All right, the main purpose in algebra or any math class of dealing with matrices is they help you solve systems of equations super fast, okay, because you can utilize a calculator or a computer, something like that, that works very, very fast. So how do we use a matrix to represent a system of equations? Okay, so look at this system of equations here, something we've been working with for a little while now. So if I want this to be put in a matrix, I need to, kind of like elimination, make sure that both equations are in standard form. So this 2x plus y equals 9, that's in standard form. This also is in standard form. Then we can go ahead and put it in a matrix. And how you do that is just take the coefficients on these and take the constant and put them in the order that you see them. So 2, 1 is implied in front of y, and then 9. And then here 1 is implied in front of x, -6, make sure and bring that minus with you, and then equals -1. Okay, so the elements in the first column represent the x, the elements in the second column represent the y, and the elements in the third column represent the constants. Okay, and depending upon the author of the book or program that you're using, sometimes you'll see some authors put a vertical line here to represent where the equals sign goes. Okay, so sometimes you'll see that line, sometimes you won't, so I just want to prepare you for that. If you look at example 2 now, we have a little bit different situation. We have 3 variable systems. So when you're dealing with 3 variable systems, very similarly, you need the order to go x, y, z equals number. X, y, z equals number. There's no y here, so that's okay. We don't have a y. And then here we have a problem because the x is on the right side of the equal sign. So we know that negative 5x needs to jump over the equal sign and go to the left side. So anytime anything jumps over the equal sign, I change its sign. So it turns from negative to positive. So 5x plus y equals 1. Okay, so now let me show you what this matrix will look like. I'm going to have 1, negative 3, 1, 6. X is 1. Remember, there was no y, so I put a placeholder of 0. And then 3, and then 12. And then here, I need to come back to this one. It'd be 5. Y is 1. Z is nothing, so 0. And then 1. And then close it off, and again, be aware you may see this vertical line here that represents where the equals sign goes. So that's your x's, that's your y's, that's your z's, and that's what your constants, what it equals. Okay, so on your notes in the writing a system from a matrix portion, there should be a bracket around this. I'm sorry I couldn't get the computer program to do it, so go ahead and write it for me. Okay, so going backwards, taking this matrix and writing a system. Remember, I told you that the first column are the x's, the second column are the y's, and the third column are the constants. Okay, so now we need to use that to write our systems. So this is going to be 3x minus 1y, I don't really need to write the 1, equals 6. Okay, and then next I've got 8x, there is no y, so I don't need to write it, equals negative 4. And there's my system. All right, last but not least, the fun part, okay, using a calculator to solve a system. So up until this point, the only way you know how to solve a system is by graphing, by substitution, by elimination, or by tables. And all of those methods take quite a bit of time. I think within time you will agree that using the matrices is probably usually the fastest method. So it's really neat that this calculator can very, very quickly find the point of intersection between these two lines. So instead of having to get out a sheet of paper and graph these, you can utilize the calculator. So how does it work? Well, first we need to make a matrix out of this system. So first of all, this 1/2 x needs to come to the other side. So that would be a negative 1/2 x plus y equals negative 2. And then here on the x and y, they need to switch spots, but did either of them jump over the equal sign? The answer there is no, so since they didn't jump over the equal sign, their signs still remain positive. Okay, so now that I've got this in the right order, let's go ahead and write my matrix. It would be negative 1/2, 1, and then negative 2. And then here 1, 1, 4, 1, 1, 4. Okay, so now how do I do this in the calculator? So power your calculator on, and then you might want to write these steps down. You're going to go second matrix, arrow to the right for math. So second matrix, arrow to the right for math, and then up to B. So second matrix, arrow right for math, and then B, which is RREF. Okay, so second first, matrix second, arrow to the right, and then select choice B, RREF. Once you've got that, then you do alpha zoom and select the size of your matrix. So alpha zoom. Okay, that's the next set of keystrokes. And then for this matrix, this is a 2-row by 3 column. So I need to scroll up and change that. 2, enter. Oops, wrong way. And then 3, enter. Okay, and then scroll back down to hit OK. And there's my blank matrix that I go ahead and type in. So -0.5, 1, -2, 1, 1, 4. So just to check, -0.5, 1, -2, 1, 1, 4. Hit enter, and this is the coolest thing in the world. So notice my answer says it's the matrix 1, 0, 4, 0, 1, 0. So let me explain what this means. Remember, the first column of the matrices were x's, this was y's, and this is what it equals. So this is saying 1x plus 0y, we don't need to write it, equals 4. And then this is saying 0x, don't need to write that, plus 1y equals 0. So it just gave you the coordinate of intersection like that. All right, so 4, 0 is my coordinate of intersection for that graph. That is so nifty. Okay, so let's look at this second example here. So especially 3 variable systems are very lengthy to solve by hand. Okay, you're talking about a 3-dimensional space, so it's a lot more difficult to work with. So using a calculator is very, very fast. Let's go ahead and write the matrix first for this system of equations. So notice this x, y, z equals number, that's in order, 1, 1, 2, 3. Here I need to switch, put the x in front, 2x plus y plus 3z equals 7. Nothing moved across the equal sign. Okay, so none of the signs changed. So 2, 1, 3, 7. Here I have an issue that negative z needs to move across the equal sign. All right, so that will change sign. So negative x minus 2y plus z equals 10. So -1, -2, 1, 10. Okay, so remember, same steps. I've got second matrix, arrow to the right for math, up to B, hit enter. Okay, alpha zoom. This is a 3 rows by 1, 2, 3, 4 column, hit enter, and then start typing away. 1, 1, 2, 3, 2, 1, 3, 7, -1, -2, 1, 10. 1, -2, 1, 10. Yeah, that looks great. Okay, so here's my answer, and I won't have you write this down every time. I just want you to get the idea of it. 1, 0, 0, 1, 0, 1, 0, -4, 0, 0, 1, 3. What does that mean? That means x, remember the first column is x equals 1, second column is y, 1y equals -4, third column is z equals 3. So my ordered triple, my solution, would be 1, -4, 3. That is the point of intersection of that system of equations.